Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Sub-Zero by MK. And here are the rules. We have normal Sudoku rules apply, with one exception. Place the digits 0 through 8 instead of 1 through 9. So in every cell in the grid, place a single digit from 0 through 8 such that there are no repeats in any row, column, or designated 9-cell region. Digits in a cage cannot repeat and sum to the small number in its corner. The 3x3 box borders divide blue lines into segments. Each segment oh, hold up. Okay. Right, so killer cages. Digits in a cage cannot repeat, so you cannot have repeats within a cage, and they sum to the small number in the corner. So these three cells must add up to -4. These three cells must add up to -7. These three cells must add up to 0, all without repeats. So keep that in mind of digits. So, what does that mean? Well, we need to read more to basically understand this. Probably the sub-zero part. The 3x3 box borders divide blue lines into segments. Each segment on an individual line has the same sum. So the sum of these two cells must equal the same as the sum of these two cells, etc., etc. The sum of this value must be the same as the sum of that, which is the same as the sum of that cell. Now, the important part, which is, I believe, the sub-zero part, is every digit that stands below a 0 counts as negative regarding summation. So that's for both the region sum lines and for the killer cages, which is how we can get -1, -7, and -4 as possible values. Because any digit that has a 0 above it will be a negative value for that digit. And there are 8 different sub-zero digits in the grid. No row, column, or 3x3 box can have more than one sub-zero digit. So in each row, there are 8 total different sub-zero digits, which makes sense, right? There cannot be a sub-zero digit in row 1, right? So therefore there are only 8. No row, because no column, row, or 3x3 box can have more than one sub-zero digit. And since none of the digits in row 1 can be below a 0, that means there must be 8. There can be 8 at most in total, and this is saying that there are 8 in total. So keep that in mind. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so let's look at cells which have... We're going to mark sub-zeros as blue, potential sub-zeros as blue. So, in box 2, the sub-zero has to be in the -1. So one of these is sub-zero, which means the rest cannot be. In box 7, one of the ones surrounding the -1 here has to be sub-zero. So that means none of the rest of the box can be. So for the -3, one of these two has to be sub-zero, which means none of the rest of the box can be. Which means for we have to add up to 0, we have to have a negative value. because you can't have repeats within the cage, so it can't be 0, 0, 0. So this must be sub-zero, which means the rest cannot be. So since this is sub-zero, that eliminates sub-zero here in the rest of the row and column. None of these can be sub-zero. So the sub-zero in this -4 must be here. Okay, so one thing is we know then this is 0. This is 0. So this is the sub-zero for box 4, which eliminates sub-zero in the rest of the box. This can't be sub-zero here. Where is the sub-zero in -7? It must be here, which eliminates sub-zero in the rest of the box, row, and column. So this is not sub-zero, which means one of these is sub-zero. So 0 has to be here. 0 is one of these two. We don't know which. Oh, this can't be sub-zero because one of these is guaranteed to be sub-zero. So therefore, this must be 0 here. One of these is sub-zero here. We don't know which one of these is sub-zero here. So we know we have a 0 here. We know we have a 0 here. We know we have a 0 in one of those two. Okay. 0 then has to be one of these two here. Okay. So these digits are the same. To get to -7, we have 0 through 8. It has to be -8 plus 1. So this is -8. This is 1 then. So right now, this sums to -8. This has to have a negative value here. Since this has to have a negative value, this portion must have a negative value to sum up to the same sum. So this must be the negative, which means this cannot be negative. So this is the 0 here, which means this can't be 0. So we know for row 1, where's the 0? It must be one of those two, because it can't be here, because this must be sub-0. So this has to be 1 through 7. So this must be at least 1 greater than that. So it cannot be -1. Sum of this is equal to that plus 0. So these sum up to that digit. This will mark as a pink. So it's the same as that digit. So it cannot be here, cannot be there. We don't know which one of these is 0. So this can't be sub-0, neither can that. So one of these two is sub-0 to be below the 0 here. Oh, this cannot have a sub-0 at all, because obviously there's no 0 above in the box that it's above or below. All the zeros here force a sub-0 there. These obviously can't be sub-0, so one of these two is. So this is the sum of two unique digits, which means it has to be 3 through... it cannot be 0, and yeah, there's no 0 here. It's at least two non-zeros unique digits. So it's 3 through 8 here. Okay, this is -1. Oh, so this is 0 plus -1 must equal -1. Therefore, this must add up to -1. So this is 7 here, which means this can't be 7 here. This can't be 7 there because they are the same digit. One of these two is blue. Okay, so we know where all the potential blue cells are. This cannot be 0. If that's 0, then that means that this is negative something, And then this would have to be positive something, which is the same as this one, to add up to 0. So this cannot be 0, which means we have a 0 here. That eliminates 0 from being in the rest of the column, so this is 0 there. Okay, so these two digits add up to something minus another digit. Okay. These are full sums. This is, of course, -1. These are all positive. This could be negative. We don't know. Okay. This is the sum of two unique digits, so this must be 3, 4, 5, 6, 7, or 8. We don't know which. Remaining digits of column 6 are 1, 2, 3, 4, 5, 6. Okay. So this digit minus this digit is -1. So this must be 1 greater than that digit. This digit is the same as that. So let's mark that as orange. That means one of these three is orange. We're not sure which. Pink cannot be any of these. Pink can't be 0. So pink has to be one of these three. Interesting. Sum of these two digits equals that digit there. So this is at least 3 digits. Sorry, 2 digits adding up to that. So this has to be at least 3 as a digit. All right. This digit is 1 greater than that, so we have 2 through 7 there. These two must equal to the same digit as that, and so this also must be 3 through 8. 1 eliminates 1 here, so there's no 1 there, no 1 there. This does not have 0. So this is at minimum 1 and 2, which is 3. 3 minus 7 would be -4. You could also have 4 here. Either way, you're guaranteed one of these is a 1. It's either 1, 2 or 1, 3 here. And 1 can't be here because of 1 in the row. So this must be 1, and this is either 2 or 3 with -7 or 8. So 1 and 2 is 3, minus 7 would be -4. 1 and 3 is 4, minus 8 would be -4, and then this can't be bigger because we don't have any other values greater than that. This, then, is the sum, cannot be 1 and 2, so this can't be 3, cannot be 4, can't even be 2 plus 3, so this can't be 5. So this is at least, so we have to add up to 6, 7, or 8, we could have 2, 4, 2, 5, 2, 6, and that's the most. Or 3, 4, or 3, 5. So we're guaranteed a 2 or 3 here. And this is 2 or 3, which means we cannot have a 2 or 3 in the rest of the box. So this has to be 4, 5, and 6 remaining. In box 5. Okay. We don't know about this. Okay, so this is -1. We have a 0 here. We have 2 other unique digits. And then we have a -1. Okay, so this is 0 with something -3. So the difference between these two digits is 3. We could have 8 and 5, 7 and 4, 6 and 3, 5 and 2, 4 and 1. And those are the possibilities. So this is a positive value. That means this digit minus this digit must equal that digit. So this cannot be -8 because something minus -8 would have to be a negative value. Therefore, this can't be -7. It could be 6. So this is 1 through 6 here. Can't be 1 because of 1 in the box. So this must be greater than that. So we have 3 through 8 there. These two digits sum up to what that digit is, so it's 3 through 8 there. This could be 1 through 6, because we have at most 8 minus 2 here. This can't be 3 or 4 because we don't have a 1 in the box. Oh, where is 1 in row 4? It has to be here because it can't be in the rest of these cells because of 1s in the boxes. Can't be here because it's the sum of 2 unique digits. This can't be 3 or 4. It could be 2, 3 here as a pair to add up to 5. So this adds up to 8 at most, so then we have 2 through 6 here. Okay. This is 1 less than that, because this is -1, -1. This is the same as that. These two sum up to what this digit is. Okay. Okay. These could be... You cannot have a 0 here. So these are 1 through 7 to add up to at most 8. This could be a negative. We don't know. The negative value here is greater than 1 plus the sum of another digit, of the other digits. So what is this negative blue value? We don't really know. Oh, that's interesting. This must be, so this digit must be 1 less than this. That doesn't tell us too much. Interesting. Okay. One aspect, though, is in column 4. Where is the 2 and 3? Only one of them is here. The rest cannot be in this situation. So that one of these has to be a 2 or 3. Which means this can never be 2 minus 3 here. So that can't be 2, that can't be 3. Because that would necessarily eliminate 2 and 3 from these 3 cells here, which means we don't have a 2 or 3 available here. Okay. This cannot be 0, 1, and 7. So we have 2, 3, 4, 5, 6, 8 here. Where is the 2 in row 4? It can't be here because of the way that this 2, 3 pair works. Can't be here because that's a sum of two non-zero unique digits. So it has to be one of these 3, which eliminates 2 from the rest of the box. So this can't be 2 there. Therefore, this can't be 6 because 6 and 3 at minimum add up to 9. The negative value here, the sub-zero value here, you cannot have a 1 be in this sub-zero circle. And because if you, as the positive value, if you have 0, 1, oh, wait, no, that's not true. 1 could be, never mind. Hmm. Hmm. 8 has to be one of these two digits in box 6. What else do we have? Hmm. To get to -1, we have 0 already in that cage, in that 4-cell cage. So we have two digits which add up to 1 less than the other digit. So you could have 1 and 2 as the positive digits with -4, 1 and 3 with -5, 1 and 4 with -6, 1 and 5 with -7, 1 and 6 with -8. So this can only be 0 through 6 here. Obviously, 1 can't be here. So the highest digit for the positives is a 6. Um, hmm. 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 um. Hmm. Oh, if this is a negative, okay. So then the negative has to be at least -4. So if this is negative, -4, that means you have at most 8 minus 4, which would have to add up to that. So this cannot be the negative, which means this is the negative, so that can't be negative. This is negative here. This has the 0 above it. Or sorry. This cannot be 0 above it. This has to be 0 above it. This must be 0 above that. So we know this is at most 1 through 6. This has to be at least 4 through 8. So these sum up to 6, 7, or 8. We could have 1 through 7 here. We don't know which. Okay. Hmm. Um... Pink cannot be any of these, so pink is in one of the four corners, which is fine. We have all the zeros. We don't have all the ones. Hmm. Okay, these two digits equal the sum up to this. These two digits sum up to that. This digit is one less than that digit. So this digit, the difference between these two digits. So this is the sum of these two. This is the sum. This is the sum of these two. Uh, hmm. This has to be 2 through 7 here. And this is 2 through 7 here. Hmm. Hmm. So one thing we know is this can never be 1 greater than this digit. Is that right? So say we had 6 and 5 here. 6 plus whatever digit, say it's 1. 6 plus 1 equals 7. 1 plus 5 equals 6. And the problem is this has to be, yeah, so this can never be 1 greater than this digit. But that doesn't really tell us much. Hmm. Hmm. Oh boy. This is actually the tough part of this puzzle. The sub-zero part was pretty easy to figure out and determine. What happens if this is 3 and 8? Is what I'm thinking. 3 and 8 means this cannot be 3 or 8. 8 cannot be here. So this has to be 2 here. So no 3 or 8 here, no 3 or 8 here. That means this pink digit must be here. Now that's interesting. That would mean 8 cannot be here, so 8 would have to be there. This is a 4, 5, 6 triplet, which means this cannot be 4, 5, or 6. It's a 2, 3 pair here. So no 3 or 8, no 3, no 2 or 3 in that case. So we have 2 with 4, 2 with 5, or 2 with 6, adding up to 6, 7, or 8 here. 8 can't be here. These can no longer be 7 or 6. So far, that's okay. So 2 has to be here in that instance. Which means no 2 here, no 1 here, no 2 here. So 2 is there, which means 2 has to be one of these 3. So far, that's looking fine. This difference between these two can never be 1. Actually, it could be 4 and 3. Never mind. Okay, never mind. This can't be 8 in that instance. This can't be 8. So this has to be 1 less than this, so it can't be 7 here. So far, this is looking fine. I was hoping we'd reach a contradiction, but right now we do not seem to be reaching that. So no 2 here, 3, 4, 5, 6. Huh. Okay. What happens if we try to make this a 6? This is 6. This is then 2 and 4. So this can't be 2. That's 3. That makes this 1 plus 3 minus 8. So this can't be 4. This 6 eliminates 6 here, so that's 5 and 6 there. Therefore, the pink is a 4, because it can't be 8 or 3. So this is 4, which makes this a 1-3 pair. Adding up to 4. No 4, 5, or 6 here, which means no 1, 2, or 3 here, because it has to be 3 different. This is still 8. We have a 2, 3 pair here. Pink is 4. This is 2 and 4. We have to have 2 and 4 somewhere here. No 2 and 4 here, which means this can't be 1 and 3 correspondingly. Okay. This is all looking kosher. No 8, no 7, no 8. No 6 here. So this cannot be 2 and 4. So 1 of 2 or 4 is guaranteed to be here. Sorry, it's guaranteed to be here. Because this cannot be a 2-4 pair here. So no 2 here, no 4 here, no 4 here, which means that can't be 5. So this has to be 2 or 4 here, guaranteed. 6, this can't be 4. There's no 6 here. No 4 here. This is 2 with 7 or 8. Six would eliminate 6 here, so that's 7. Therefore, this is 6. 6 minus 7 is -1. There's no 6 here. This can't be 6. No 6 here. This cannot, since this can't be 6, this can't be 5. So far, this is looking fine. Dang it. 7 eliminates 7 here. So this is 2, 8 as a pair, which means this can't be 8. It's 7 minus, that's negative 7 plus 4 is negative 3. There's no 4 here, no 4 here. Which means this can't be 4, so that's 2. No 2 here. We're guaranteed one of these is a 4. So since one of these is 4, it must add up with at least 1 to give us 5 or 7. It cannot be 4 and 5 here. So 5 or 7 requires this to be 4 or 6 here. 2, so this is 1 or 3, which means 5 has to be one of these two. This can't be 5, so we have 1 or 3 here. We have 5 and 8 with 1 or 3 here. This is working. I was hoping it would lead to a contradiction. If this is 1, 4, that means this is 5, which makes this 3 and 3. Otherwise, this is 3, 4, which means this can't be 3 either way. No difference of 4 here. No difference of 6 anymore because it can't be 8 minus 2 here. 2 plus 1 adds up to 3. 2 plus 3 adds up to 5. 2 plus 4 adds up to 6. This adds up to 6 here. So it cannot be 2 and 4. It must be 1 and 5. So eliminates 1, 5 in the rest of the row. So no 1, 5 here, no 1 here, no 5 here. So it cannot be 2, 3 adding up to 5. It's 2, 4 adding up to 6, which means this can't be 6. This must be 4 and 5. That leaves us as 1 and 4 here to add up to 5, which is negative 5, and we have a contradiction. That was really convoluted. Okay, well, I don't know if I like that. Anyways. So this cannot be 6 here. Do we try 2 and 5, and then 2 and 6 more? I guess. Okay. 2 and 5, that's 3, that's 8. No 3 or 8 here. This then has to be 5, that's 5. This has to be then 7. That's 4 and 6. This is 8. No 3, no 2, 3. This has to be 2, 3 here. So we have 2 and 5 here. There's no... Oh! Interesting. Okay, no 5 or 7, which means no 2 and 4 there. Again, you cannot have 2 and 5 add up to 7, and we have to have 2 and 5 in this set. So that means this is 2 or 5 no matter what. No 7 here means no 6 there. No 6 there, no 5 there. This can't be 5. It cannot be 2. So no 4 minus 5. No 2 here, so this can't be 1. So this is 3. If 3 minus 4 is negative 1, 6 minus 7 is negative 1. So we know 2 has to be one of these. This cannot be 5, 6, or 7. It's 1 through 4 there. There's no 5 here. This adds up to 7. No 5 here. Hmm. Unfortunately, it's not as cut and dried in this case. Hmm. Okay, what happens if we make this 3, 4? What happens if we make this 8? Hmm. I'm just not spotting where the restriction's coming from here. Yeah, if this is 8, oops. If that's 8, this must be 7 and 2. 1, 2 is 3, minus 7 is negative 4. So 7 cannot be here. 8 can't be here, so this must be 8. Well, that's one thing we figured out then. This can't be 7. If this is 7, it must add up with 1 to add up to 8, but 7 would eliminate 7 being here. And 7 and 1 would force that to be 8, which eliminates 8 there, so that's not possible. So this cannot be 7. That doesn't really help very much. Again, we're trying to make this 8. So if this is 8, this can't be 8. So that's 8, that's 8. That's fine. That makes this 7. Ooh, that's interesting. So this is 7 and 2. Which means this must be 3 and 4 here. So far that's okay. No 7, 8 here. No 4, 5 here. 7 eliminates 7 from being here. This can't be 4, 5. It's 5 or 6 there. We don't know. So this is pink, which forces that to be 8. So no 4 here, which means this can't be 3. 3 has to be one of these 2 here. That's fine. So this adds up to 8. You can't have 2 4s. 1 would have to be with 7. This cannot be 4, 5. It has to be 4. This can't be 5 or 6 or 8. This is 2, 3, 4 as a triplet. No 3, 4 here. No 2, 3, 4 here. Okay, no 7 there. Does this tell us anything? This can't be 7 there. Not particularly. So these cannot be 3. There's no 3 there. This is 8 minus 2, which, okay, this cannot be 4. 8 minus 4 would be 4 here. So 8 minus 2 is 6. 8 minus 3 is 5. This guarantees has a 5 or 6 here. So I don't think this can be 4 either. 4 plus 5 adds up to a minimum of 9. So this is a 2-3 pair here, which would force this to be 4. Interesting. So this is guaranteed then. If this is not 8, it has to be a 4. This is 2 and 5 at minimum, so this would be 7 or 8 here. So if this is not 8, it's 4. So that's one thing we've learned from that. Interesting. Kind of convoluted way of doing it, but So this has to be a 4 or 8. Guaranteed. This can never be 2. Because this can't be 2. So we have a guaranteed 2 there. So again, let's keep going down that path. 8 forces this to be 7 too. Which means this can't be 8, so we have 8 here, 8 here. This can't be 8, it's 7. So 3 always has to be with 4 here. 2, however, could be with 5. 2 could be with 6 here. That's interesting. So that forces this to be 4. 7 is here. No 7 there. No 7 there. No 6 there. No 4 here. No 4 here. So no 3 there. No 7 or 8. No 4 or 5. No 7 there. It adds up to 7. No 4 here, no 4 here. This can't be 1. Guaranteed 3 here, so none of these can be 3. No 4 here, so no 4. Since this can't be 3, this can't be negative 4. Does this help? I don't really know. No 7 here. 7 could be any of those 3. Okay, not helpful. Well, I mean, I guess it gave us a little bit insight, but not too helpful. Okay, what happens if this is 8? If this is 8, that means it has to be 2 and 6 here. Which means this is 3 and 8 here, so this can't be 8, so that's 8 there. That's fine. No 3 here. No 4, 5, or 8. This can't be 3, so this must be 6 in that case, which forces this to be 2 and 3. No 3 here. We have 2 and 6 here. This can't be 8, so this is guaranteed to be a 2 or 6 there. 8 eliminates 8 from being here. So this can't be 2 or 6 either. Which means this must be 2 and 6 here. Obviously, none of these could be 2 or 6. No 6 here. This has to be a 1. 6 plus another digit cannot add up to 8 anymore, so it has to be 6 and 1. So this is 1. That means this is 1, 2, adding up to 3, and 6, 2, 6, 1, adding up to 7. So this becomes a 3, 7 pair. That means no 1 here, no 1 here. This is 3, 4, and 5. So this cannot be 4, 5, and 6. You can't have negative 2 here, so this must be negative 7 with 3, 4, or 5, which is a contradiction because it doesn't add up to negative 1. So this cannot be 8. Interesting. That's interesting. So we know this is a 7. That's very interesting. So this can't be 7, this can't be 4, this can't be 7 anymore. 7 is either going to be 2, 5, or 3, 4 here. So we have a guaranteed 6 here. So this cannot be 6. That means this can't be 6 either. Oh boy. This is the long portion. So this can't be 7 here because it sums up to 7. Hmm. Okay. Maybe we go through each of these possibilities to try to eliminate ones. So 3 here means a 1, 2 pair here. That means this can't be 3. This must be 2. This must be negative 7. So no 3 or 7 here. This cannot be 2 or 5. It's 3 and 4. Which means this can't be 4. So this has to be 8 here. No 3 or 5 here. It's 2, 4 as a pair. This is 3. We have 3 and 4 here. 3 has to be one of these. So no 3 here. Since this can't be 3, this can't be 4. No 3 there. No 3 there. No 8 here. No 7 here. No 4s here. So this difference cannot be 6, cannot be 5. This seems fine. Okay, no 3 here. Hmm. I wonder if each sub-zero digit has to be unique. That's the only way that I'm seeing that this can have a solution. Because this is very, very, very broad. Because the problem is 8 different sub-zero digits in the grid is kind of ambiguous. And I'm thinking that it has to be the digits 1 through 8. Because there's no way, I don't think, that we can come up with a solution which doesn't have that if these are not unique. Huh. And the thing is, it hints at that with it saying 8 different sub-zero digits in the grid. The problem is that I'm guessing that it has to be unique. I wish they had said there are 8 unique sub-zero digits in the grid, because then that completely blows away the ambiguity. With the 8 different sub-zero digits, the different could be mean to be, oh, well, there are 8 cells or whatever that have sub-zero digits. I'm guessing that this is what it has to be, because otherwise, right now, I'm not seeing enough restrictions here to basically be able to show that this is the case, right? And I don't imagine that it would be this convoluted to try to solve. So, if that's the case, this has to be a -1. This has to be -7, so that's 2, which makes this 3 and 4. So no 4 here. This can't be 1, so it can't be 3 or 4 here. No 3 or 4 here. It's 5 or 8. So there's no 7 here. We cannot have a 4. It's either 2, 3 adding up to 5, 2, 6 adding up to 8, or 3, 5 adding up to 8. So this can't be -8 or 7. I just don't see that as a possibility. This can't be -7, so this can't be -6. Because I feel like it's way too unrestricted to be able to be the case. This is 5, 6 as a pair then, which means this can't be 5. It's 8 here. That's 8 here. That means the pink doesn't really help. Okay, well. Because we know that's 8, that's 8. We have a guaranteed 3 here, so this is 3, 4, 5, 6 as possibilities. This can't be 8, so that can't be 7. No 6 here, because that can't be 7. This is 4. So this must be 8 here with 2 and 3. This can no longer have a 3. So we're guaranteed a 3 here. This is adding up to at most 6. 4 can't be here, so this can't be 3 there. We have 1 minus 2 is -1. 4 minus 5 is -1. 5 minus 6 is -1. This 4 eliminates that possibility there. 2 and 3. This can't be 3 or 4. So this has to be 7 or 8 here to be either 2 and 5 or 3 and 5 or 2 and 6. 8 minus 2 is 6. 8 minus 3 is 5. So no 4. This can't be 3. This can't be 4. Yeah, I feel like it's way too broad otherwise. So one of these two is going to be a 4. This can't be 1. And this can't be 7 or 8. So cannot be... This can't be 4, because if we try to have 4 here, that would be 2 and 3 at minimum, which is 2 and 3 minus 4 is negative 1. So this has to be 2, 3. This must be 6. That means none of these can be 6. So that would force 4 to be here. So it's 4 and 1. This can't be 1, 2, or 3. Because of the 1, 2, 3 triplets, or 2, 3 pair in the box. And this can't be 6. No 7 here. 5, 2, 3 eliminates 2, 3 there. So this has to be 5, 6 with 2 and 3 to add up to 8. 6 eliminates 6 here. This digit is 1 less than that. So it cannot be 5. It's 2 or 4. This can't be 6, so this can't be 5 there. 4 eliminates 4 from being here. 4 has to be one. This can't be 4. There's no 4 here, so 4 has to be one of these two. Whereas 7 in this box, it has to be here, so that's 7 there. Yeah, I don't think it's solvable if you don't assume the uniqueness for the sub-zero digits. So this is guaranteed to have a 2 or 4 here, because it's 2, 5, or 3, 4 adding up to 7. This is 2 or 4. That eliminates 2 and 4 in the rest of this row. So the rest of this row cannot... Okay, where is the 7 in this row has to be one of these two. This adds up to 3 or 5. So this cannot be 5 here. So either way, we're going to have a 2 here. So because it's either 2, 1 adding up to 3 or 2, 3 adding up to 5. So this must be 2 here, which means this can't be 2. That's 3, which makes that 2 and 5 adding up to 7. 3 eliminates 3 here, so that's 5. So this must be 2, 3 adding up to 5 there. This can't be 2. This can't be 5. So this has to be 6 in both of that case, which means this can't be 6. That's 5, which is 8 minus 3. Therefore, this is 2 there. 5 and negative 5 and 4 add up to negative 1. No 2 or 3 here. No 6 here. This is either 1, 3 adding up to 4, which it can't, or 5, 3 adding up to 8. So this is negative 5, so this must be negative 2, which makes that 1. So no 1, that leaves that as a 4. This must be 3, 5 as a pair, which eliminates 3, 5 in the rest of the column, so this can't be 5. That's 6, which makes that 5. That leaves that as a 7. We have a 1 here because of the only remaining digit in row 8. No 5 here. 7 eliminates 7 here. So whereas the 7, it has to be here. It also eliminates 7 here, so it's 8. 8 is the sum of 2 and 6. That makes this 5 here. So there's no 5 available here. Okay, we have all the zeros. Do we have all the ones? We do not. It's not that restrictive. 2s. We don't have that. Remaining digits of row 5 are 3, 4, and 5. Remaining digits of column 5 are 6 and 8. Yeah, there's no way, unless assuming that the sub-zero digits are unique, that we can have that. Yeah, I wish they had used unique. Different implies something else. It can usually mean uniqueness also, but it's not always the case. Column 8, remaining digits are what? 1, 6, and 2. Obviously, this can't be 6. This can't be 2. This can't be 1. Interesting. Remaining digits of column 9, we have 1, 3, and 9. 3 cannot be here. This can't be 1 because of 1 in the row. So we're guaranteed a 3 in one of these two cells. We don't have that anymore. Column 7. We have, what, 2, 3, and 7. But 3 cannot be either of these, because 3 is guaranteed to be here, so 3 has to be here. And this becomes a 2, 7 pair. This can't be 2 because of 2 in the row, so that's 7, which makes that 2. This can no longer be 2 and 6, adding up to 8. It's 3 and 5. So the orange doesn't match up. 5 eliminates 5 here, so it's 3. Whoops. It's 3 there and 5 there. 2 eliminates 2 here, so it's 1, which makes this 6, which makes that 2. How do I have a 1 and 9? That's all wrong. Okay, hold up. It's 1, 4, and 3. Okay, but again, this can't be 3, so we're guaranteed a 3 here. That doesn't change any of this. So therefore, this must be 3 here. 4 eliminates 4 here, so it's 1, which makes that 6 and 2. 1 eliminates 1 here. 2 eliminates 2 here, so that's 1. This must be 2 and 7. 2 eliminates 2 here, so it's 3 and 5. Orange is not correct. 6 eliminates 6 here, so it's 8 and 6. That leaves that digit as a 4. No 3 here. 3 eliminates 3 here, so that's 4 and 3, which eliminates 3 here, so it's 5 and 3. That's 3 in the corner. We celebrate because we're close to solving this. No 3 here, no 5 here, so this must be 4, which makes this 3 and 4. No 3 or 4 here, it's 5. 4 eliminates 4 here, so it's 6. 4 and 6 eliminates 4 and 6 here, so it's 2, which makes this 3. Remaining digits in row 1 have to be 2 and 8. This can't be 2 because of 2 in the column, so that's 8 and 2. This digit has to be 7. This digit has to be 4 and 6, and this can't be 4 because of 4 in the column, so it's 6 and 4 there. That leaves this as an 8 and this as a 7. Yeah, I really wish they had used a different word than different, because different can mean many things. Unique is a much, or even distinct. Distinct works also. There are 8 distinct sub-zero digits in the grid. Unique, I feel, distinct also has some ambiguity, but there it's less ambiguous. Different could be used for many different connotations. So it's just like, oh, I don't know. Maybe that works, maybe it doesn't. Ugh. Yeah, but that would have saved me a lot of time to figure this out, because I didn't know that there was but after basically trying it for a while, I was like, this doesn't seem like it's restrictive enough unless I have the restriction that every sub-zero digit must be unique. Yeah. Very cool puzzle. The idea is very interesting too. I guess I just wish that word different had been unique instead. Anyways. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.